Okay, so let's do a little bit of review. So when we're talking special triangles, do you guys remember what this is? Root 2 over 2 and root 2 over 2. Hey, check this out. Let's see how we derived this before. Remember if this was, let me cover this up for a second. Remember if this was n, or what was it? This was x? If this was x, then this was for 2. Let's make this 1. Let's make our lives easier. If this is 1, what's this? And what's this? Just root 3. Remember that? Okay. So if I want to make this 1, how could I make, this is how I should have taught this the first time. If I want to make this 1, what would I do? If I divide this by 2, don't I have to divide everybody else by 2 as well? It's so clear now. Right? Yeah. It works the same with this. Do you guys remember if this is, what was it? If this is 1 and this is 1, then what's this? 1 square root 2 or just root 2, right? How would I make this 1? Divide by root 2. Divide by root 2. But what's wrong with it? You can't have a root. So when you multiply by root 2 over root 2, it's root 2 over 2. You see it? So that's how those are derived. So this, if this is 1, what's this? Root 2 over 2. Root 2 over 2. Are we ready? Are we good? And we need that for our unit circle. Correct? Okay. Okay, so this is 1, 0. This is 0, 1. This is negative 1, 0. Let's use our special triangles. We were just reviewing to fill this guy out. So if this says 30 degrees, that means that this line created here made a 30-degree angle. If this is a 30-degree angle, then what would this angle be? Uh-oh. This is the one I want to keep. Why am I having such a hard time? It's on the right one. Oh. Just kidding. Okay. Right there. Like you guys said, this would be 60. If this is 60 and this is 30, what's this side?
Root 3 over 2.
Root 3 over 2. And what's this side? 1/2. So what would this coordinate be here? I have to go over on the x, how far?
Root 3 over 2.
Root 3 over 2. And up 1/2. Right? Now this other triangle here is the same triangle, only flipped. So if it's flipped, wouldn't I just have to switch my coordinates? Correct? Because it's now, the 60-degree angle is here. I can erase it. Now it looks like this. And my 60-degree angle is here, and my 30-degree angle is here. Therefore, this would be what? Root 3 over 2, and this one would be 1/2. So I would go 1/2 on the x and root 3 over 2 on the y. Correct? This one's the easiest one because the 45, the coordinates are square root of root 2 over 2. You should see from my point. It's like, listening, that's funny. All right. Let's finish it off. All right, so if this way going on the positive x is root 3 over 2, then what would be going on the negative x? Negative root 3 over 2. Am I going negative on the y? No, it's just 1/2. And this one would be the opposite. I would be going negative 1/2 and positive root 3 over 2. And this one would be negative root 2 over 2, positive root 2 over 2. I think I covered all of that. Okay, so if I had, my choices were, let me change my color. If my choices were pi over 6 and pi over 4 and pi over 3, which one is the smallest? 6, because a sixth of something is smaller than a third of something. So this is pi over 6, pi over 4, pi over 3. And you stop there and you say, well, if this is pi over 6, this far, this much of a pi, it's almost like we could take this and rotate it. It's not going to work for me. But I'm rotating it, right? And then I'm rotating it again. It doesn't, does that help at all? Mm-hmm. So there's another piece of it if I were to rotate it. Get it? And then another piece if I were to, whoa, would rotate it. So how many pi's would that be? Pi over 6, 2 pi over 6, 3 pi over 6 would be pi over 2. And this would be, how many pi's over 6? This was 3. 4 pi over 6, which is really what? 2 pi over 3. And this would be, count, 1, 2, 3, 4, 5 pi over 6. And this would be 6 pi over 6, or just 1 pi. Right? So that fills that part out. What's the only thing left? Quarters. So let's do that one in purple. If this, oh no, we still need blue. If this is a quarter, right here, see that arc right there? If that's a quarter of an arc, wouldn't this be 2 quarters? Wouldn't this be 3 quarters? And this would be 4 quarters, or pi. I'm not going to fill in the degrees, but I do want to talk about, this would be 0 pi. All right, let's talk about pi and degrees. Pi equals 180 degrees. Doesn't that mean 180 degrees equals pi? So, couldn't I substitute? What would that be? 1. What would this be? Okay, so I'll review. Correct? This is what we've already done. Can I move on? I think I covered everything I wanted to cover. I will be able to describe angles and angles of measure. I will be able to describe what a coterminal angle is. Okay, so this is a lot to say. I'm going to read it and I'm going to explain it. On a coordinate plane, an angle may be generated by the rotation of 2 rays that share a fixed endpoint at the origin. Here's your origin. They share an origin. Here's your 2 rays. It's kind of weird because they didn't make this one a ray. I'm going to make it a ray. Okay, that's a ray. That's a ray. They're sharing the same origin. Correct? One ray is called the initial side. This ray is called the initial side because it's starting right there at 1, 0, or at 0 pi, or at 0 degrees. I think something that the last class didn't understand is that when you're talking degrees, you're talking degrees. When you're talking radians, you're talking radians. But you don't go back and forth between them. So if you have a question that's talking to you in radians, what are you going to answer them in? Radians. Okay? All right. So this one's called the initial side. Where the angle ends is called the terminal side. So it says an angle positioned so that its vertex is at the origin. So if this is the origin, it's the vertex is the angle's vertex of the initial side and the terminal side of the angle. If it is along the positive x-axis, lying right there, this is standard position. This is a standard position here, angle. Questions? All right. It's kind of like something you just have to start working with it. So, kind of. Not, did we? Yeah, we did a little bit. Yeah, we did, exactly. So, positive angle measure, counterclockwise. So we normally go in a counterclockwise direction. So this is an example of an angle that's 225 degrees. What would its complement be? The other part. So how would you find that? 360 minus 225, what would that be?
135.
So this angle is 135, right? But did it ask me that angle? Maybe this will help, because I was trying to, this was a little bit difficult. But what I was trying to do was I was trying to explain, do you guys see that that's negative 135 degrees? Because I started from the standard position and I went in the opposite direction. Does that help? So this is 225 degrees and this is negative 135 degrees. Okay. So this one says negative angle measure. So if I'm going in the negative direction, this shows you that it would be negative 210. Okay? Good? All right, draw an angle with the given measure in standard position. In standard position means where am I going to start? I'm going to start right here. No, this is called the initial side, right? So I'm going to start here, my initial side, and I'm going to go around. How far do I have to go around?
A little bit more than 1.
I have to go more than 360. So there's 360. How much more do I need to go? So 450 minus 360 is 90. I need to go 90 more. So I would end right there. And what do I call this end? No. The end is called what? The terminal side.
Smaller. I didn't ask my question.
No more. No more asking that question. Okay. So goes around 360 and ends there. That would be a 450 degree angle. Okay? All right. What would I do with this one? Go the other way. How far am I going to go? Well, if this is 90, I would have to go how many more?
21 degrees.
20 more degrees? So like, less than that, because this would be 45, right? So probably about right here? All right, you guys want to write that down? Why would it be 190? Let's go back, because I forgot to push record. So, and this answer is wrong for some reason. If I want to convert degrees into radians, I would put 180. Do you remember it's 180 degrees for pi? Right? So 180 degrees is equal to pi, so this is really 1 over 1, right?
Oh.
Make sense?
They just took out 10 from cross multiplying and then add 19.
No, it's not cross multiplying. It's saying I have 19 times 10, and down here I have 18 times 10. 10 divided by 10 is 1, so I'm canceling out 1. So I'm left with 19 pi over 18 pi. So what am I going to do with this one? 3 pi over 8. What do I need to get rid of? The pi. So where's the pi going to go? In the denominator. What's going to go in the numerator?
180.
180. Why?
180 equals 1 pi.
Yeah. Yeah, because these are equal if you're trying to convert it. Yep. So when I do that, you know me, I like to cancel stuff. So if I cancel a 2 out of there and cancel a 2 out of there, I have 90. Cancel another 2, I would have 45. What's 45 times 3 divided by 2? 67.5. Yes. I don't know. Thank you. I appreciate it. Because I made a mistake. I was going too fast. Yep. Okay. How long does it take for a minute hand on a clock to pass through 2.5 radians? I love this one because it sounds so complicated, but it's not. Where would I start? Where does the clock start? No. It starts right there. Which way does it go? In the negative direction, according to this. First of all, it's not standard position, right? Second of all, it's going in a negative direction. Okay, so let's start here, and let's do 2.5 radians. So 2 radians would be where? How far would I have to go around to get 2 radians?
All the way back around.
All the way around, because one full rotation is 2 pi, right?
And half would be 45.
Half would be here, right?
An hour and 16 minutes.
So my terminal side would be at here. And how long did I travel? An hour and 15 minutes. That's it.
Top end would be at 1.
It would be at 1. You're right. 1:15? We good? I could have physically done that, you know. Like, no, like this. Go all the way around, and then a little bit more.
Break all the gears.
Yes.
No.
Okay, guys, ready?
Run out of parts.
Guys, this is the last one I have to do, and we have about 8 minutes to do it. And this is the most complicated, so I need you guys to pay attention. Stop rustling the papers. Just stop passing them back. I need you guys looking up here. All right. So find one angle with positive measure and one angle with negative measure, coterminal with each angle. What do you think coterminal means? What? They end in the same spot. They both have co-lines together, right? Coterminal, co-rays, right? Coterminal means they're both there. Like co-captains?
Yeah.
Both on the same boat, right? All right, so coterminal. So if 15 degrees is right here, correct? If that's 15 degrees, then what would be, it's kind of like geometry, what would be its complement? Negative what? How far would I have to rotate? I would have, let me do it with a different color. To be on the same line, coterminal. I would have to, if I had to start here and go this way, then I would have to start here and go. Now they have now they're coterminal. So in order to find that, didn't I just take 360 and subtract 15 from it? 345? But it's not 345 because I went in the negative direction. It's negative 345 degrees. So it asked me to find a positive measure and a negative measure that are coterminal. There's my negative measure. How would I find a positive measure that's coterminal? I would go in the positive direction. How far would I have to go in the positive direction before I was coterminal again? 75? 375. Why 375? Let's change the color again. We'd have to go all the way around and add 15 more? I could have. I just decided to go, you're going to want to go in the negative direction and the positive direction. So now they're all coterminal, right? And how far did I go?
375.
I went 360 plus 15, which was 375 degrees. Yep. The coterminal angle.
You add the degree and subtract it again.
Okay? That actually isn't the only answer. Couldn't you go around 2 rotations and add 15? Couldn't you go around 10 rotations and add 15? Wouldn't that be a coterminal angle? So these are possible answers. As long as it lands on there, as long as it's coterminal, it's the correct answer. All right, so I'm going to take a picture of this and drag it over here so you've kind of got this as an example. For this one, because, you know, I'm going to put this in on blue for you. All right, and I'm going to erase this. Now let's do the other one. All right, this one's a little more complicated. You guys ready? Let's start with where it is. Where is negative pi over 4? If this is pi over 4, what would negative pi over 4 be? In the negative direction, right there. Make sense? Instead of rotating to pi over 4, we're rotating in negative direction pi over 4. So there's negative pi over 4 right there. So you got to go in the negative direction and the positive direction. Well, we're already in the negative direction. So let's go in the positive direction and see what happens. How far would you have to go to get coterminal? No, this is what I was talking about. Forget degrees. No, forget the degrees. Pretend like 7 pi over 4. We're not talking degrees anymore. We're talking radians. So if this right here is negative pi, if this is negative pi over 4, no, still the wrong one. Negative pi over 4, then isn't going in the positive direction 7 pi over 4? So one of them would be 7 pi over 4. So I went this way. Now which way am I going to go? Back. How far would I have to go back? Negative. Let's do it on the inside. Negative. How far is it going all the way around? 2 pi plus another.
Negative pi over 4.
So I'm going negative 2 pi plus another negative pi over 4.
Negative 8 pi over 4 plus
This is negative 8 pi. Isn't negative? I want him to have common denominators. That's what he's doing in his head. Wouldn't that be negative 8 pi over 4?
Yeah.
And negative pi over 4 is how many pi's over 4? And that's as hard as it gets. That's where we're at. See where it landed? It's right there.
How do you know how to count?
It's there. It's right there.
She was taught when she was like little.
No, listen. If we want to get to here, right? It tells us what the angle is right there. Jesus, do you see? It's right there. It tells us that's 7 pi over 4. It's just, okay, guys, I need you to stop talking and pay attention. If I were, pretend like it was degrees, Jesus. If I told you, how far would we be going if I went this far? From 360 to 3, what is that? 315. How far did I go? That's 45 degrees. If I were to tell you, go negative 45, please stop talking. Stop shuffling and stop talking. If I were to tell you to go negative 45 degrees, and then I told you to give me a coterminal angle that was the opposite of that, wouldn't that be going in this direction and I would land at 315?
Yeah.
Same thing. Okay, does that make a little more sense?
Yeah.
Kind of? Kind of. So here's our options, or our answers. What other options would we have?
Going around.
Going around a bunch of times and landing somewhere. Okay? Does that help? All right, so describe a coterminal angle on your stamp sheet, please. Good job, guys.